Project code ITPW16. Project title: a three-port LLC resonant DC to DC converter. In the proposed DC to DC converter, we have to use the input port and output port. The input port here used solar PV and battery, and output port battery and load. Why we using the battery as the input and output means battery have the capable of both charging and discharging. So in a title says three port. So the input port, in case input port is 2 means output port is 1, or output port is 2 means input port is 1. And the LLC means inductor capacitor is coupled in a proposed DC to DC converter. It have the capable of reducing the ripple. In existing concept, the isolated three-port bidirectional converter. Why we saying as a isolated converter means in normal DC to DC boost converter, uh, i- this circuit is a normal boost converter. There is no isolation in this converter, but in a proposed converter, the input side and the output side in between one coupled inductor is placed. Nearby the coupled inductor, we have to place the LLC format. Inductor coupled. We know that you all know that LC inductor and capacitor coupled to get this undistorted output. But again, inductor is placed to get the again high low ripple output. In the input side, connected PV and battery, and the output side connect the load. Why we are say the bidirectional converter means in case we did not satisfy the load demand, in case load is not connected with the in a grid means the panel voltages have reversely and come to the battery and charge the battery. So this converter is called as a bidirectional converter, not a single way, it also the both way it will communicate. The existing system drawbacks: it is very low efficiency in existing DC to DC converter, because here we using the three-port converter means the one DC to DC converter is used, and again boost converter is used, again buck boost converter or bidirectional converter is used. This separate circuit and combined, these are all complicated, so it is get the low efficiency. In a proposed converter, the three-port DC to DC converter with the LLC topology is used. The proposed advantages is isolated. Generally, using the coupled inductor in an input and output part, this coupled inductor have to reduce the electromagnetic interference problem. This is a black diagram. The input port is connected with our proposed converter and connected to the load. And a proposed converter having some switches which is controlled using the pulse width modulation technique. And again, in a proposed converter, other storage element like battery is used to connect in a port. The main application is in case in the future the fuel cell technology is used, so we replace the PV with fuel cell in a future in future. So in a fuel cell does not require any input for the, because in a PV we get we will give some solar irradiation. In solar irradiation change means PV does not work properly. So the fuel cell is a future development. So in application fuel cell, and it is also used for the electrical vehicle application also, and the DC and the AC grid application also. This proposed converter is used. This converter is did using the MATLAB Simulink, and in a prototype the microprocessor lab software is used to fed the program to our prototypic controller to get the pulse for the proposed converter. The hardware, mainly the MOSFET and transformer and PIC microcontroller and other passive and active devices are used. So our proposed converter, the main aim is three-port operation in a single converter. In conventional converter have only the two port, input and output port. An additional one port is added in our proposed converter, and it is a isolated nature. It's an isolated boost converter. And third advantage is it is a bidirectional. These are all the advantage of our proposed converter. Thank you.